All right, today we're going to be solving a system of linear inequalities. You know how to solve equations. We've done that with graphing. We've done that with substitution. We've done it with elimination. When we're solving a system of linear inequalities, this one you need to do by graphing. And you'll see why in a minute. So I guess let's get right to it. Let's take a look at a problem that's a system of linear inequalities. So here is a system of linear inequalities. We have y minus x minus 3 is less than or equal to 0, and we have 2x plus 3y is greater than negative 6. So the first thing we want to do is put the equations into slope-intercept form. It's the way most of you are more comfortable working. So again, once you have the problem and the problem's been assigned to you, it becomes your problem. You have to figure out how you're going to solve the problem. And I think for most of you, it's going to be easier to do it this way. So let's add x to both sides. So now we have y minus 3 is less than or equal to x. And then we'll add 3 to both sides. So we have y is going to be less than or equal to x plus 3. So that's going to be our first equation. So we know y is going to be less than or equal to x plus 3. Okay? Now we're going to turn the other equation, which is sort of in standard form there, we're going to turn that also into slope-intercept form. Again, this is something you guys already know, so this shouldn't be that hard for you to do. So the first thing we're going to do is we're going to subtract 2x from both sides. So now we have 3y is going to be greater than negative 2x minus 6. And then we'll divide both sides of the inequality by 3. So y is going to be greater than negative 2/3 x minus 2. So that's going to be our second equation. Y is going to be greater than negative 2/3 x minus 2. Okay, so now we're just going to kind of clean this up a little bit so we could put our graph actually on the same page and you can see what the graph looks like. All right, so we'll do our first equation. I guess we'll do that in blue. A couple things that you need to know when you're graphing an inequality as compared to graphing an equation. Anytime that you have a less than or equal to or a greater than or equal to, that means you're going to have a solid line. And you'll see what I mean, what the difference is. Compared to having a less than or a greater than, which means you're going to have a dashed or dotted line. And the reason for that is the equal to allows points that are on the line to be included in the solution. If it's just greater than, the line itself is not included because it has to be greater than the values on that line. Okay, so it's a little subtlety, something that you do need to know. All right, so now we're ready to graph. We'll graph the first equation. Y is less than or equal to x plus 3. And we'll go up to our positive 3. And our slope is 1, so it means we're going to go up 1 over 1. And we would go down 1 over 1, like that. Okay, I'm going to get my straight line tool here, which I'm sure you guys are all familiar with. Okay, and let's turn this, we'll make this one red. Okay, so we can connect this, and we'll have our first line. And again, if you remember what I said, the fact that it's a less than or equal to allows us to have a solid line as compared to a dashed line. Okay, I always like to label my lines when I draw them. So y is going to be less than or equal to x plus 3. That's this one. The second line I'm going to do, and I'm going to do this one in blue, is y is greater than. We'll do the less than in a minute. I just want to get the lines on the board. So y is greater than negative 2/3 x minus 2. So I'm going to have to draw that line. Again, I want my straight line tool. Okay, and this time my line is actually going to be a dashed line. Because again, it's just greater than, it's not equal to. So I'm going to create a dashed line here. And my y-intercept is at negative 2. So let's get our points going here. So we'll start at negative 2. and then we're going to have negative 2/3. So it'll be up 2 to the left 3, up 2 to the left 3, like that, down 2 to the right 3. So that's going to be where that line goes. Let's graph that line. Make sure we're blue, and we're good to go. Okay. So there's that line. Okay, so now I have my lines drawn. Now, like I said, the difference is these are inequalities, not equations. So we require some shading on these problems. So going to our first one, which is our red line here, okay, we need to shade less than or equal to that line. So a couple ways we can do this. The first way, and this is the way that you do it in the textbook, is you pick a point on either side of the line. Obviously, in this case, we want to choose 0, 0 because it's an easy point to put in. So we would substitute 0, 0 in for x and y. And if we do that, we're going to see that 0 is less than or equal to 3. Then we have to see if that's true. That means that the point that we chose is on the correct side of the line. So then we would actually shade that side of the line. Now you're going to shade this whatever way you feel you need to, okay? But this is what would be shaded. Everything that is on that side. The way I like to think of it is find the point where your line crosses the y-axis. In this case, we cross the y-axis right here. Okay? And the fact that this says less than or equal to, all values of y that are less than that point, which is at y equals 3, have to be on the shaded side. So y equals 2 has to be on the shaded side, y equals 1, y equals 0. All of those points have to be on the shaded side. So you can shade it that way instead of having to go through and substitute a point in. If you're not 100% confident, don't worry about it. Put the point in. Not a big deal. Okay, and then we're going to do the same thing with the blue line. We have y is going to be greater than negative 2/3 x minus 2. Hopefully some of you are thinking about this already, saying, well, if less than meant I had to shade underneath the line, or lower, greater than means I have to shade above the line, which is true. So again, we can pick the 0, 0 point because it's not on that line. And if we put in 0, 0, let's see what happens. So we get 0 is greater than negative 2, which is also true. So that means we're going to be shading above this line because this point is above the line. So now we're going to be shading in this direction. Okay, so now we have this whole thing. The actual answer to the question, the solution to this problem, is whatever is shaded in both colors. So that's this piece in here. Right? This whole thing here is our solution. Okay? And the way I like to have the students, or my students, label this anyway, is I like to put a big S in there to stand for shaded. So you see how I'm going along that line? And I'm going to come right back up the blue. So that's telling me that this is shaded. Obviously, you can see from all the different colors that this is the solution that we want. So if you were asked to provide a point that is a solution to this system, any point that is shaded in all the colors. So you could choose this point as a solution, this point is a solution, this point is a solution, and because the red line is solid, it's again less than or equal to any point on the red line that is above the blue line, that's greater than the blue line, would also be a solution. So this is how you graph and solve a system of linear inequalities. Thanks for watching.